As we discussed in the previous video that the position vector in plane polar coordinate can be represented by two quantities or can be written as a function of two quantities r and theta, where r is the distance from origin to the location of the particle and theta is the angle which the position vector makes with x-axis. Now at time t the particle is at point A. After a small interval of time like t plus delta t, the particle reaches to point B. At point A, the position vector is r and the unit vector along the direction of position vector is this one, this r cap. While at point B, the position vector is r cap r plus delta r, while the unit vector in the direction of this position vector is r cap plus delta r cap. If we look at here, this position vector r cap, its direction is this one, r cap, while the unit vector, while the direction of this unit vector r cap plus delta r cap is slightly different from r cap, which is this one, r cap plus delta r cap, and where delta, the angle is delta theta, which is this angle. Now we need to calculate this change in unit vector from r cap to r cap plus delta r cap, which is delta r cap. As we know that if a particle is moving in a circular path where radius r, suppose the particle is at point A and after some time it reaches to point B, this distance from origin to A or B is r because it's the radius of the circle and it's make a small angle theta. Okay, so this arc length s can be calculated by using this relation s is equal to r theta. The same approach we will apply here because the particle is moving in a curved path from this point to this point, from A to B, and we need to calculate this arc length S, which is delta r cap here. Now using the same approach, then this arc length delta r cap will be equal to this r cap times delta theta. Now both this equation is scalar equation. Similarly, this equation will also be a scalar equation. If it's a scalar equation, then this means that this unit vector r cap is basically the magnitude of the unit vector. If it's the magnitude of the unit vector, then its value should be equal to 1 because we define a unit vector as a vector having magnitude equal to 1. Like a unit vector is a vector with magnitude equals to 1. So if it's equal to 1, then this relation now reduced to delta r cap is equal to delta theta. If I need to convert this scalar equation into a vector equation, then I will introduce the directions here. Now if you look at here, delta r cap direction is this one, which is equivalent to this theta cap direction. So it means that if I convert this equation into a vector equation, I will put the direction here, which is along the direction of theta cap times delta theta. Now dividing both sides of this equation by delta theta, we get this relation, and applying the limit such that delta theta, this angle from point A to point B, approaches to 0, delta r cap over delta theta is equal to theta cap, and this terms is basically the total derivative d r cap over d theta is equal to theta cap. This is one very important equation. Now if we look at the direction of theta cap, okay, theta cap is represent the direction along the angular direction. Okay, its direction is something like this. This and this are parallel, while theta cap plus delta theta cap direction is different from this theta cap, which is this one. This is theta cap, this is theta cap plus delta theta cap, and this is the angle delta theta. This is delta theta. Now I have to calculate this change in unit vector from theta cap to theta cap plus delta theta cap, which is delta theta cap, which can be calculated by using the same approach which we define here. So delta theta cap is equal to this theta cap times delta theta. Again, this is a scalar equation. If it's a scalar equation, then this unit vector will represent the magnitude of the unit vector, which will be equal to 1. If I put this value, then delta theta cap will be equal to delta theta. Now I have to convert this equation into a vector equation. If I convert this into a vector equation, then I will introduce the direction here. The direction of delta theta cap is this one, okay, which is basically anti-parallel to this one. If this is r cap, then this will be minus r cap, because suppose we have a vector A, then its negative vector will be represented like this, and it is represented by minus A. So the direction of delta theta cap will be minus r cap. So delta theta cap will be equal to minus r cap. We introduce the direction here times delta theta. Dividing both sides of this equation by delta theta, we get this relation. Applying the limit, delta theta approaches to 0, delta theta cap over delta theta is equal to minus r cap. This will give us the total derivative d theta cap over d theta, which is equal to minus r cap. This is another very important equation. I will use these two equations, this equation and this equation, again and again in my rest of the calculation. Now suppose, as we know that a vector can be written in the form of this one. A vector has two parts. One is its magnitude and the other one is its direction. Now if we have the position vector, this position vector, then this position vector can be written as its magnitude times its direction, because its magnitude is r and its direction is this r cap. Now if I differentiate this equation with respect to time, I will get d over dt of r into r cap. Now this side dr over dt, the rate of change of position vector, the rate of change of displacement, will give us the velocity, which is dr over dt, which is equal to, now apply this operator on this quantity, we get dr over dt times r cap plus r dr cap over dt. Now velocity will be equal to dr over dt times r cap plus r. Now dr cap over dt, which I can write like this, dr cap over d theta times d theta over dt. Now as we know that dr cap over dt, which is equal to r dot, we represent it as like this, dr over dt is r dot, the first derivative of r with respect to time, times r cap plus r. Now dr cap over d theta, we already defined it here, which is equal to theta cap, and d theta over dt is theta dot. So velocity will be equal to r dot r cap plus r theta dot theta cap. This is very important relation. I will explain it after deriving the relation for the acceleration. So here I will just write the relation for the velocity, which is r dot r cap plus r theta dot theta cap. Now differentiate this equation with respect to time, like dv over dt, which is equal to d over dt of r dot r cap plus r theta dot theta cap. Now the rate of change of velocity is basically acceleration, which is equal to, apply this differential operator on this quantity, we get dr dot over dt into r cap plus r dot dr cap over dt plus dr over dt theta dot theta cap plus r d theta dot over dt into theta cap plus r theta dot d theta cap over dt. Now acceleration will be equal to dr dot over dt basically represent the double derivative of r with respect to time, because dr dot over dt is equal to d over dt and r dot it is itself dr over dt. So this is equal to d square r over dt square, so it's equal to r double dot, and r cap plus r dot dr cap over dt can be written as dr cap over d theta over dt plus dr over dt is r dot, and then we have theta dot and theta cap plus r d theta dot over dt is theta double dot, and theta cap plus r theta dot and d theta cap over dt is d theta cap over d theta into d theta over dt. Now acceleration is equal to r double dot r cap plus r dot dr cap over d theta is equal to theta cap, and d theta over dt is theta dot plus r dot theta cap plus r theta double dot theta cap plus r theta dot and d theta over d theta cap over d theta is equal to minus r cap. So in terms of this I will write minus r cap, and d theta over dt is basically theta dot. Okay, now the acceleration becomes r double dot r cap plus r dot theta cap plus r dot theta cap, this one, plus r theta double dot theta cap, this relation, minus, because there is a minus sign, r theta dot square, because theta dot times theta dot is theta dot square into r cap. Now separate the terms containing r cap from the terms containing theta cap. The terms containing r cap is this one, r double dot, and this one, minus r theta dot square, and the terms containing theta cap is this and this. If we add them, we get 2 r dot theta dot and this term plus r theta double dot. This is another equation. Now if suppose we have the same situation, particle move from point A to point B, so along radial vector r we have the unit vector r cap, and along the angular direction or the tangential direction we have the unit vector theta cap. So the terms which containing r cap will represent the radial acceleration or radial velocity, because velocity is r dot into r cap plus r theta dot into theta cap. Now this contain this r cap unit vector, so this r cap unit vector, so it means that this term represent, this is velocity, okay, so this term represent the velocity, radial velocity, plus this term contain theta cap, and theta cap represent the tangential direction, so this will be the tangential velocity. So radial velocity is, the magnitude of radial velocity is r dot, and the magnitude of tangential velocity is r theta dot. This is radial velocity and this is tangential velocity. Similarly, the acceleration contain two terms, this one and this one. This contain r cap and this contain theta cap, so this is the radial acceleration, radial, and this is tangential. So the radial acceleration is AR, which is R double dot minus R theta dot square, and the tangential acceleration is A theta, which is 2 R dot theta dot plus R theta double dot. This is all about plane polar coordinate system.